Hi, I'm Gabe Rouse, and this is my presentation on power generation and distribution. So, a little introduction to power generation. So, a quick definition is a process of converting energy into electrical power, and some of those power sources we get that energy from can be fossil fuels, whether that be coal or natural gas, nuclear energy, or solar, wind, and hydro, which are forms of renewable energy. So, the role of generators is to convert mechanical energy into electrical energy through electromagnetic induction. And a quick overview of that is when a conductor, such as a wire coil, is exposed to a changing magnetic field, an electromotive force or voltage is induced in the conductor. So, next, let's go over transmission lines and transformers. So, the function of transmission lines is to carry electricity over long distances from the power plants to substations. So, energy is generated at power plants and then is transferred over to substations. And we use high voltage transmission in this transmission over long distances for efficiency and reduce energy losses. And some of the roles of transformers in this process is voltage conversion, efficient power transmission, and grid interconnection and compatibility. And all these factor in for the safety, efficiency, and efficiency of the transferring electricity over long distances. And some of the materials used in transmission lines include conductors on the inside and insulators on the outside, which is pretty basic. And then for the transformers, we have core material of iron or steel and a coil material of copper or aluminum for optimal conductivity and performance. So let's go on to power distribution grids and smart grids. So an overview of power distribution grids is that they deliver electricity from substations to consumers. And components of distribution grids include distribution lines, transformers, circuit breakers, and distribution panels, which are all used to correctly, safely, and efficiently deliver the electricity to the consumers. And a little introduction to smart grids is the integration of digital communication and control technologies. So, energy storage systems and future trends. So, the importance of energy storage systems for grid stability and integration of renewables. There's a big importance for it. And some of the types of energy storage are batteries, which we all know what batteries are, pumped hydro storage, which is a type of hydroelectrics energy storage where water is pumped from a lower reservoir up to a higher reservoir during periods of low or high electricity demand um, to manage electricity demand and supply. And then also flywheels, which are a mechanical energy storage device that store rotational energy by spinning something that has mass, in this case a flywheel, at very high speeds. And the role of energy storage in balancing supply and demand, especially in intermittent renewables, and some future trends in power generation and distribution include increased use of renewables, advancements in energy storage, and grid modernization with smart technologies. So there can always be improvements to making a system safer, more efficient, um, better for the environment, and those are some things that we're looking for future trends.